Just imagine, a company that became famous for making cell phones decides, out of nowhere, to drop a bomb on the electric vehicle sector. We're not talking about rumors or vague promises, but something real, concrete, and with numbers that would make any engineer scratch their head. Huawei, yes, the same Huawei that makes smartphones, has announced an all-solid-state battery with a range of up to 3,000 kilometers. That's right, 3,000. It's the kind of news that seems like science fiction, but it's about to become reality and could turn the automotive market upside down. The energy density of this battery? An unreal 500 watts per kilo. That's almost double what we have in current cutting-edge batteries, like those from Tesla. What's most intriguing is that this technological breakthrough didn't come from an automotive giant like Toyota or Ford, but from a company that, until recently, no one took seriously in this segment. And that's where the game starts to change. Huawei not only came out with a shocking announcement, but also revealed technical details that show that this is not just marketing talk. They're dealing with next-generation technology, based on materials that push the known limits of battery engineering. And the entire industry has started to pay attention. And of course, when we talk about solid-state batteries, many people turn up their noses because of the classic problems: rapid degradation, instability, and difficulty in mass production. But Huawei guarantees that it has solved these obstacles in an ingenious way. What's more, this battery is not only more powerful, it is also safer, lighter, and easier to integrate into the car's system. This opens up space for vehicle architectures that were previously unfeasible. More compact cars with the autonomy of an SUV or SUVs with the range of an airplane. Can you imagine the impact? Perhaps the most interesting thing here is the symbol of this movement, a technology company entering the race to dominate a centuries-old industry with an ace in the hole that no one expected. It's as if a rookie team reached the championship final with a secret strategy that no one can stop. The message is clear. The era of combustion engine specialists is being challenged by specialists in chips, algorithms, and disruptive innovation. And when these worlds collide, revolution comes with force. The most striking part behind the scenes is the silence of its competitors. No one expected a company like Huawei to make this leap. And while traditional giants are still in their infancy with prototypes, the Chinese seem to have turned the key straight to the future. Of course, we don't have this model on the streets yet, but the fact that the company has announced such a technology, with a registered patent and production targets under study, has already put the entire automotive sector on high alert. Another thing worth highlighting is the timing. Huawei launched this new product at a time when the world is undergoing an accelerated energy transition. Governments are tightening their grip on fossil fuels, incentives for electric vehicles are spreading, and more conscious consumers are demanding more autonomy and less headaches when recharging their cars. In this scenario, coming up with a battery that can run almost 2,000 kilometers without stopping is simply strategic and brilliant. Now comes the second piece of this puzzle that is keeping traditional car manufacturers awake at night: charging time. Because there's no point in having a monstrous battery if it takes forever to charge, right? And that's exactly where Huawei seems to have hit the nail on the head again. The promise of charging in 4 to 5 minutes is something that borders on the unbelievable, especially when you consider the current industry standard. Anyone who has ever owned an electric car knows waiting 30 minutes on a fast charger is still considered good. But 5 minutes? That changes everything. To achieve this feat, the company claims to have solved one of the biggest Achilles heels of solid-state batteries: accelerated degradation. That classic problem where the interface between metallic lithium and solid electrolyte breaks down over time, reducing capacity and safety. Huawei's solution? Using a technique that sounds like something out of a science fiction lab: doping sulfide electrolytes with nitrogen. Complicated in name, but brilliant in practice. This creates a stable, resilient interface that maintains efficiency even after hundreds or even thousands of cycles. And the most interesting thing is that this isn't just laboratory talk. Huawei has filed a patent for this innovation, indicating that it has moved beyond the theory phase and is working to scale up production. In other words, this isn't the old coming soon to cars story that has dragged on for years. They are actually ready to take the next step. What does this mean? The expectation is not only to have more autonomy and more safety, but also faster recharging, with a level of stability that we have not yet seen in any other commercial project. Just imagining being able to stop at a station, plug in the cable, and leave 5 minutes later with over 300 kilometers of autonomy, you can already feel that the game has changed. This completely eliminates that argument that many critics still use against electric vehicles. Oh, but what if I'm in a hurry and the battery is empty? That fear simply ceases to exist. Recharging becomes as quick as filling up with gasoline. In fact, even quicker in some cases, if the technology delivers what it promises. Of course, there is a delicate point here: cost. This battery, despite all this progress, is still not cheap. The current estimate is around $1,200 per kilowatt, which is about 20 times more than a conventional LFP battery used in popular models. But if you think about it, it's the same path that happened with OLED screens, smartphones, and the first electric cars. At first, everything was prohibitive. Then it dropped, and dropped a lot. The logic here is the same. It starts with luxury models, but inevitably goes down to affordable cars. Meanwhile, companies like BYD, XPeng, and Zeekr in China are already field testing similar technologies. Ultra-charging stations are being rolled out at a rapid pace in Europe, the US, and even Australia. The idea of charging a car like grabbing an espresso is becoming a reality. And with giant tech companies investing billions in research, the pace of development is set to be even faster than in the past. The electric vehicle market is like a giant chessboard, and every unexpected move changes the game completely. And with Huawei advancing like this, it's impossible not to notice the devastating impact this innovation could have on its competitors. This is no longer a race for autonomy or charging speed, but for technological survival. If companies like Toyota, Samsung SDI, and even Ford don't accelerate their projects, they could simply fall behind. Or worse, be swallowed up by a market that's changing at a rocket pace. The most curious thing is that, for years, these automotive giants comfortably led the way in battery development. They invested heavily, created laboratories, promised new products, and then they just kept floundering. Meanwhile, Huawei arrived quietly and, all of a sudden, made a breakthrough that not even the most optimistic forecasts expected. This turnaround exposed something that few people like to admit. The traditional automotive industry is moving slower than innovation demands. And that, in an electric age, is dangerous. Because the truth is that consumers are changing. Nowadays, no one wants to wait. Those who buy an electric car want practicality, performance, safety, and, above all, novelty. And if a brand doesn't deliver that, someone else will. This is where Huawei's coup hurts even more. It wasn't just technological, it was strategic. They understood that the game is no longer about making beautiful cars or powerful engines. The game is now about who dominates the battery. And they decided to lead that part. And there's another detail that's scaring competitors: China's scale. While traditional automakers are struggling to adapt factories and train staff to produce solid-state batteries, Chinese companies have dozens of gigafactories under construction, with flexible production lines and highly skilled workforces. This means that when Huawei's battery is ready to go to market, it won't be produced in small batches or in luxury prototypes. It can go straight to the masses, with aggressive pricing and massive volume. This threat is already being felt. Rumors indicate that engineers at Toyota and Volkswagen are on high alert. Pressure has increased to speed up internal projects. because if it takes another 2 or 3 years, it may be too late. The public will not wait forever for promises, and neither will investors. In an industry where innovation is the most valuable currency, those who stand still lose more than market share. They lose relevance. Another point that reinforces this impact is the change in the axis of technological power. Before, everything revolved around the United States, Japan, and Germany. Now, China appears as the nerve center of the energy revolution, with companies like KTL, BYD, NIO, and now Huawei setting the pace. This changes the entire dynamic of partnerships, public policies, and even tax incentives. Countries that were previously comfortable with their domestic industries are now forced to make more room for Chinese products, or risk being left with what is left. At this point in the story, a name that could not be left out of this conversation emerges: 24M Technologies. This North American company is also causing a buzz in the sector with its Eternality battery, and for good reason. Unlike Huawei's approach with all-solid batteries, 24M is betting on a radical advance within the universe of liquid batteries, keeping the electrolytes in a fluid state, but with improvements that border on the spectacular. The energy density? No less than 660 watt-hours, which makes it the densest liquid battery ever announced to date. But here comes a fascinating comparison. On one side, the 24M, with its technology based on improved liquidity, and on the other, Huawei betting everything on absolute solidity. The fight is good. The 24M's battery promises charging in 4 minutes for 300 km of autonomy, excellent performance in freezing temperatures, and Nobel Prize-worthy safety. All this without requiring mega infrastructure or deep industrial rework. In other words, it can be implemented in current factories with minimal adaptation. And that, for automakers, is music to their ears. But here comes the but. When it comes to safety, thermal integration, and durability, Huawei's battery starts to gain ground. That's because, while the 24M still uses flammable liquid, as advanced as it is, Huawei completely eliminates that risk with its solid, non-flammable electrolyte. This means that even in collisions or electrical failures, the risk of fire is virtually zero. And in the automotive world, where billion-dollar recalls due to fires have become commonplace, that makes all the difference. Another factor that weighs in the balance is design. Huawei's solid-state batteries do not require such robust cooling systems or such thick protection plates, which frees up space inside the car for more useful energy. Even though the density per kilo of the 24M is higher, the total volume used tends to favor Huawei. This means that, in the complete system, the one that actually goes inside the car, the difference can be reversed, giving the Chinese solution an advantage. And this puts everyone on alert. 24M, on the other hand, is well-positioned to meet immediate demand. Its greatest asset is its ease of adoption. It can be licensed, quickly integrated into the current production chain, and hit the streets before the boldest competitors. This could yield valuable contracts with manufacturers who prefer to take things one step at a time. But here comes the question: will taking small steps be enough when others are taking giant leaps? And it's worth remembering that Eternality also faces limitations. As revolutionary as its internal separation, with the famous impervio layer, there are still risks typical of liquid batteries: dendrite formation, gradual loss of capacity, and dependence on advanced thermal control systems. Huawei, on the other hand, with its nitrogen-stabilized interface, promises much longer and more stable life cycles without aggressive degradation. And if they can deliver this at scale, it will be a game-changer. And if there's one name that can't be ignored in this conversation, it's Tesla. The arrival of a revolutionary battery like Huawei's raises a question that's on everyone's mind. What about the Model 2? That $25,000 car, which Elon Musk has been promising as Tesla's game-changer, could be just the right place for this new technology. And if that happens, we're talking about a change that goes far beyond reach. It's a complete shift in the concept of affordable electric mobility. The Model 2's proposal has always been bold, a cheap car with good autonomy and designed to conquer emerging markets. But until now, all of this depended on a battery that was cheap, safe, compact, and efficient, something that seemed impossible to balance. But with this solid battery from Huawei, with 3,000 km of range, thermal safety, and the potential to become cheaper over time, this balance is starting to seem closer than ever. And the craziest thing about all of this? It can transform a popular car into a real spaceship on wheels. Just imagine, an entry-level Tesla with more range than a Model S Plaid. It may seem like an exaggeration, but that's exactly what's at stake. With this technology, Tesla could offer a car with 1,500 to 2,000 kilometers of real-world range using a smaller and lighter battery, which would also reduce the cost of production, transportation, and maintenance. This would open the door to markets where charging infrastructure is still poor, such as Latin America, Africa, and parts of Asia, places that Elon Musk has already expressed interest in exploring. And there's more. This solid-state battery would meet the criteria for tax incentives in several countries, since it eliminates flammable heavy metals, is easier to recycle, and reduces environmental impact. This would put the Model 2 directly in the most advantageous subsidy brackets in the United States, the European Union, and even India. In short, Tesla would be able to do something no one has done before: a global car with high range, low cost, and tax exemption. This is a market dream. Of course, the immediate adoption of this battery in the Model 2 is still speculative. There is no official confirmation, and it is known that Elon Musk likes to keep his cards close to his chest until the last minute. But the clues are there. Tesla has already filed several patents related to solid-state batteries, is testing new anode and cathode materials, and may very well be developing an experimental model in parallel with the Gen 3. The pressure to innovate has never been greater, and Musk loves to compete when the challenge is technological. But the magic of this battery doesn't stop at cars. What Huawei has presented has the potential to completely transform the concept of energy storage, including off-road. And here comes a technical detail that few people realize, but that makes all the difference. This battery is capable of operating in extremely adverse conditions, such as negative temperatures and isolated environments, without losing efficiency. This opens up a range of possibilities that goes far beyond urban transportation. Think of the most inhospitable places on the planet: Tibet, Scandinavia, Alaska. These are regions where conventional batteries suffer, lose capacity, and often become unviable for critical applications. Huawei's battery, on the other hand, does not rely on flammable liquids, does not require aggressive heating systems, and can withstand extreme cold without risk of freezing or failure. It is the kind of solution that can power medical equipment, signal repeaters, navigation systems, and even vehicles on scientific bases in these hostile environments. Another fascinating point is that this battery can discharge to 0 volts without suffering structural damage. For those who are not in the industry, this means that it can go to the limit of energy without compromising its useful life. In off-grid applications, such as solar farms,